All right, you guys, we've reached the last section of composite functions. All right. So one important technique about using composite functions is that in calculus, sometimes you will be required to determine the components of a composite function. All right. So an example of that would be find functions f and g such that f composed of g equals h if h of x equals x squared plus 1 to the 50th power. Okay, so all of the examples we've done so far, they've given us an f function and they've given us a g function and asked us to compose them. So if you want to think about it like the ingredients to a cake, they gave us the milk, the eggs, the flour, and told us to bake the cake. Now what they're trying to tell us to do is that they've given us the cake and they want to know, well, what was in this cake originally? Did you have eggs? Did you have milk? Did you have flour? So we're going in reverse. Okay. So one thing I want you guys to do, I don't want you guys to overcomplicate these problems. Okay. You really just take these problems for face value. Okay. So really what you're going to be doing, you are looking for, all right, an inside function. Okay. And you are looking for an outside function. Okay, that's all you're going to be looking for. You are looking to see if you see one function that could possibly be sitting inside of the other. Okay, so for this example here that they gave us, x squared plus 1 to the 50th power. Okay, so if you look just at face value, this x squared plus 1 is sitting inside of parentheses. So if I wanted to, I could call x squared plus 1 my inside function. So if it's the inside, it has to be sitting inside of something. So if I were to replace where that is with an x, I could say, well, it's sitting inside of x to the 50th power. That's my outside function. Okay. And since we're doing f composed of g, your inside function, what we're calling it, is your g of x. And your outside function is your f of x. So you have just determined the components that make up your composite function. So if you were to actually compose it like we've been doing, if you were to say f composed of g of x, you would put g of x everywhere there's an x in the f function, which would give you back x squared plus 1 to the 50th. Okay, so they are asking for these two individual functions. All right, so let's look at some more examples because I know that can be a little different. All right, so I've pulled some problems from your homework. Okay, so this first one says find functions f and g so that f composed of g equals h, and h of x, they told us, is 3x plus 1 to the 5th power. Okay, so in this definition, f composed of g, they've actually told us this. Oops. Okay, where g of x is going to be our inside function. So they told us that that equals h. Okay, so g of x is going to be our inside. Okay, and f of x is going to be the outside function. So that's how you can think about it. So we're looking for a function that sits inside of the other. Okay, so if we're looking at this problem, well, 3x plus 1 is sitting on the inside. Okay, so since we're looking for inside, that must mean that g of x for this problem is 3x plus 1. Okay, so it's got to be sitting inside of something. So if we take that out and replace it with an x to the 5th power, that's our outside function. That's what it's sitting inside of. So f of x must equal x to the 5th power. Okay, so we're going to look for the answer choice that matches our decision. So A is out. We have no radicals, so that's out. All right, so let's see. C and B have the same functions, but you got to make sure they're in the right place. So remember, we said our inside function, which is g of x, should be 3x plus 1. All right, so that means that C is our right answer. Okay, notice that B had the same functions, but they had them reverse of what f of x and g of x is. So it's important to remember who's your inside function and who's your outside function. Okay, all right, let's try another one. Okay, so same deal. They want us to find out who the inside and outside functions are, who f of x is and who g of x is. So remember, by this definition that they gave us, f of g of x equals h, okay? So we know that g of x is going to be the inside function, and we know that f of x is going to be the outside function. So when we look at the problem that they gave us, well, x squared plus 17 looks like it's inside of that radical, okay? So because that's the inside function, we're going to say g of x equals x squared plus 17. And we have to look at what is it inside of. So if we replace the highlighted with parentheses, okay, it's sitting inside of the radical function. So that means that f of x equals square root of x. Okay, so once again, we're going to look at our choices. So let's see. Our g of x should be x squared plus 17. All right, well, this has a g of x, x squared plus 17. All right, so these two are out. All right, so once again, C and D have the same functions, but remember, we have to put g of x with the right function and f of x with the right function. So C has them in the wrong order. So D is our answer. Okay, so if it helps you, think about these functions as inside and outside, and then making sure that you only look at it for face value. Do not make these problems more complicated than they need to be. Okay, I hope this helps.